All right. Hey, good morning, guys. Hope everybody's doing well again. Another snow day, another remote day here. So, again, hoping to be more productive with the video than we would be with a live class. So, we're going to continue reviewing probability. With I think that confusion that we had the first day, I think we cleared a lot of it up yesterday. I think with today being fully remote, we're going to bump our quiz to Monday. Okay, so that gives us today, gives us tomorrow to work on these problems. All right, and look, I think it's a difficult chapter, but we spent some time on it. We've reviewed. We might have to do some stuff on our own this weekend. We might have to go a little bit more above and beyond preparing in what we normally do. All right. So here's what we call conditional probability. All right. Here's a review for it. Here's going to be the problem where you want to make a tree diagram. All right. And I think that is going to help. That's going to be a problem. Something I ask you to do on the quiz. All right. So you're going to have problems like we've done to this point. You're going to have to make a Venn diagram. You're going to have to analyze the two-way table. And then finally, I'm going to hold you responsible for a tree diagram. All right. So hopefully today's practice really kind of puts you in a good position here. So on the Centerville High School debate team, we have a percentage of sophomores, juniors, and seniors. All right. Now, how the debate team works is there's a closing argument for the team. Okay. And depending on who gives that argument, there is data that gives us the likelihood of the team winning the debate. So if the sophomore gives the closing argument, if the junior or if the senior, we have probability that that team then wins the debate. All right. So we're going to make a tree diagram from that. And here's how we're going to do it. It's going to start with we could just say team. And that team is comprised of sophs, juniors, and seniors. All right. And we have the probability that if we were to randomly select a member on this team, what are the chances that it is a sophomore, junior? So basically, it's like the, proportionality of the team, like the makeup of the team. The team is made up of 20% sophomores, 35% juniors, and 45% seniors. All right, so there's no freshmen on this team. Because how do we know that? Well, again, didn't mention it, but also 20, 35, and 45 would add up to 100. So that's our first branch. Now from there, the second set of branches is going to basically be, the closing argument. And then if done by that particular grade, the likelihood they win the debate. All right. So this would be, let's see, if a sophomore gives it, it's going to be a 0.25. If a junior gives it, it's going to be a point. You know what? Sorry. Let me actually label win-loss first, and then we'll go back and we'll put those numbers. So the outcome's either going to be a W for a win, an L for a loss. Right? So 0.25, 0.6, and finally 0.85. So the more experienced debater, the senior, a more chance of winning. Now, notice, we're not adding those up, right? Like those would give us way over 100, but what we're doing is we're trying to figure out each branch here should be the equivalent to 100%. So that's 0.75, that's 0.4, and this is 0.15. And remember, if I multiply a branch times a branch, in other words, if I say, all right, the probability a sophomore and wins the debate with the closing argument. Branch times a branch would give me this, soph and win. All right, so that likelihood by multiplying 0.2 times 0.25, I get 0.05. So 0.2, right, times 0.25 is 0.05. Because the question here is find the probability the team wins the debate. Well, they can win 3 different ways. But I'm not just adding those 3 numbers. I have to get to that branch. I got to multiply. So there's 3 ways you can win. You could be a sophomore and win. You can be a junior and give the winning argument. Or you could be a senior and give the winning argument. So 0.35 times 0.6 is 0.21. And 0.45 times 0.85, right? First branch times the second branch equals 0.3825. Now, remember, not that we need this right now, but I just want to point it out. Remember what that second set of branches are, right? Like this whole set of branches on down, right? Those are givens. So if I were to ask you, given the student is a sophomore, what are the chances, and gives the closing argument, what's the chance the team loses the debate? 0.75. Given the student is a senior and gives the closing argument, the likelihood the team wins would be 0.85. So these are all givens. Givens are different than and statements. The likelihood of a sophomore and a winning debate, a junior and a winning debate, different. All right, so for us to answer part A, you're going to have to draw the tree diagram. Got to multiply correctly after we set it up, hopefully correctly. And then understand that to get our final answer here, I'm running out of space, I need to add 0.05 plus 0.21 plus 0.3825. All right? And that total is my final answer, 0.6425. That's the chance that this team wins the debate. All right? Now, continuing with conditional probability, we have that given formula that I've spoke about. And you don't need to memorize it, but you got to be comfortable with it. Okay? I'll provide you with this. A given B, all right, equals the probability of A and B and the probability of B. Now, what you would have to do is then put it in context. So when it says the probability of the team, given that they lose the debate, what's the probability that it was a junior who gave the closing argument? So probability junior, gave the closing argument, given the team lost the debate. So probability of junior and lost divided by the probability the team lost. All right, that's how we have to set it up. Now, this one's slightly different than the ones we've done in class, but I think we're smart enough here to kind of figure this out. The problem that I would give you on the test or quiz would look similar. It would be something like, okay, well, you're going to use your answer in part A to answer part B. But think about this. In part A, we figured out the probability that the person wins the debate. So how do you think we'll figure out the likelihood the team lost the debate? Right? 1 minus 0.6425 gives us 0.3575. That's the chances they lost. So that's our denominator. All right? So oftentimes there's not work in like how these problems are structured. Usually you have the answer to the denominator, whether it's very direct or maybe slightly indirect like this one was. But again, the work we did in part A led us to knowing that denominator. Now, the numerator, I just have to understand the notation. Junior and lost. So 0.35 times 0.4. Right, so 0.35 times 0.4 is 0.14 divided by 3575 would give us our answer. So you should get, and hopefully you're kind of pausing it and you punch it in the calculator, get your own answer just to make sure you're doing it correctly. All right. And you could say, about 39%. That would work as well. All right. So guys, hopefully that made sense. I'd like you to watch that video. And in preparation for tomorrow's class, I would like you to try this problem on your own. Now, I will help you set it up, and then you can kind of go from there. All right, so parking for students is very limited. Those who arrive late have to park illegally and take their chances getting a ticket. Joey has determined the probability that he has to park illegally and that he gets a parking ticket is 0.07. He recorded data last year and found that because of his perpetual tardiness, the probability that he will have to park illegally is 0.25. Suppose that Joey arrived late once again and had to park in a no parking zone. Can you find the probability that Joey will get a ticket? All right. If not, explain what additional information is needed in order to find the probability. All right, so I want you to give it some thought. I want you to try to set up a tree diagram and think about how this would work. Think about the branches. All right. Think about the order the events would happen. Think about the probability that we're given here to start out with. All right, that determine the probability he has to park illegally. All right, is 0.07. I'm sorry, and gets a parking ticket is 0.07. All right, the likelihood that he has to park illegally to begin with is 0.25. All right, so think about that. Think about how he parks and then the chances of him getting a ticket. So let's say the first branch would be he parked legally. The other branch would be an illegal park job. All right, so this number we're given is 0.25, right? Which means 75% of the time. All right, I forgot. I didn't want to really give that to you, but just wanted to kind of start you out. So I'll stop here. From here, you go and you make another set of branches. Okay? And see if you can set it up. See if we have enough information. But again, just try to make sure you understand the process of setting it up. Okay? And hopefully this problem just builds on problem one. All right, but guys, take these notes. I'll definitely check in to start class, and we'll go from there. All right, see you tomorrow.